In this video we're going to look at solving simultaneous equations algebraically. We're going to use the elimination method to solve these equations. The first thing I would like you to do is put a wee dot, call that equation 1, equation 2. Now what we want to do is try and eliminate one of the unknowns. So if you have a look, you will be able to see clearly there is the same amount of y's in both equations. There is 4y in each equation. That is the indicator then that eliminating the y is going to be the easier thing to do. The other thing is you look at the signs of the y. So they are both positive for y. So if the signs are the same, then what you do is you subtract. So the first thing we're going to do is we're going to say eliminate. We'll just abbreviate that to eliminate elim y. So that tells us we're going to get rid of the y's. And it's good that you're not going to get any marks for doing this, but it just keeps you right. Now how we're going to do that is we're going to do equation 1. Take away equation 2. If you do equation 1, take away equation 2, you have 5x minus 3x, which you know is just going to be 2x. You have 4y minus 4y, which is just going to be 0. And then you have got 8 minus 4, which is just going to work out to be 4. So you have 2x is equal to 4. So it's now just an easy equation. X then is equal to 4 divided by 2. So x works out to be 2. And I like to put that in a wee box just to keep me right. So I know I found my x is equal to 2. What you then want to do is sub that value into your first equation. So we're going to put that into equation 1. So everywhere you see x, it has been substituted by 2. So it's now 5 times, instead of x, it's 5 times 2 plus 4y is equal to 8. Tidy that up, it's a bit of a mess. 10 plus 4y is equal to 8, which means 4y is equal to 8 minus 10. Again, tidy up, that's going to be 4y is equal to minus 2. Y then is equal to minus 2 divided by 4, which means y is equal to minus 1/2. Okay, we will put that in a box as well, a bit messy, but there you go. And what you can also do is you can check. Now it's very important. Earlier on, we used equation 1. We subbed in equation 1. So you must check in another equation. So in this case, we've only got one other equation, which is 2. So we're going to check in equation 2. So the left-hand side of equation 2 is 3x. Instead of x, we're going to write 2 plus 4 times minus 1/2. And you can work that out. 3 times 2 would be 6. 4 times minus 1/2 would be minus 2. And 6 minus 2 is equal to 4. So I know I'm right. So we can say answer, A and S, x is equal to 2 and y is equal to minus 1/2. Next example, again, we're going to do a wee equation 1, equation 2. And have a look and you will see that your b's, you're going to eliminate your b's because you've got the same number of b's in both equations, but notice the signs of the b's are different. One's positive and one's negative. So you have to, this time, we're going to say, first of all, that we're going to eliminate b, and we're going to do that. The signs are different, and the signs are different, then you add. So if you add 5a plus a, you're going to get 6a, and if you add positive b plus minus b, they cancel out, and 8 plus 4 gives you 12. So 6a equals 12. A is equal to 12 divided by 6. A works out to be 2. And again, we'll put that in a box. Same method as before. You're going to sub into equation 1. So everywhere you see a, you're going to replace it with 2. So 5a plus b is equal to 8. So then that becomes 10 plus b is equal to 8. B then is equal to 8 minus 10. So b works out to be minus 2. And we can check in equation 2 again. So we can say just check in 2. This is a nice thing in an exam to do because then you know you're getting the marks. A was the same as 2. B was minus 2. And if you do that, 2 minus minus 2 really is the same as 2 plus 2, which is 4, which is what we wanted. So we'll just write down your answer, A and S. And you had your A was equal to 2. And your b was equal to minus 2. Next example, we have 5x plus y is equal to 22. Call that equation 1. 2x minus 5y is equal to 25. Call that equation 2. Now, again, in this one, we're going to have to do something a wee bit different. It's going to be definitely going to be easier to eliminate the y's, but you haven't got the same number of y's in both equations. You've got minus 5y and you've only 1y in this equation. So we're going to have to do something a wee bit different. We're going to say what we're going to do. We're going to eliminate y. And how we're going to do that is we're going to do 5 times my equation 1. Now notice I put this down first before I did any multiplying. Now this really explains it. Probably don't get any marks for doing this in an exam, but this explains what you're doing. So I'm doing 5 times my 5x is going to give me 25x. 5 times my y will give me 5y. And 5 times the 22. 5 times 20 is 100. 5 times the 2 gives you 10, so it's 110. So we're really trying to eliminate our y from equations 2 and the equation which I had labelled 5 times equation 1. So now we look at these and you can see that there's the same number of y's in both equations, but the signs are different. So that means we're going to add. So I'm really doing equation 2 plus the 5 times equation 1. So 2 plus 25x is 27x. Minus 5y plus 5y cancels out. And then that's going to be 125 plus 110 is 135. So x is equal to 135 divided by 27. So x is equal to 5. Again, we will put that into a little box and same old story as before. We're going to sub into equation 1. So our equation 1, which was 5 times x plus y is equal to 22, which means 25 plus y is equal to 22. Y then is equal to 22 minus 25. Y is equal to minus 3. Okay, and again, what we could do is check in equation 2. So we'll just say that where I can see my equation 2, we'll say check in equation 2. Your equation 2 was 2 times x, that's now 2 times 5, minus 5 times my y, which is minus 3. If you did that out, you're going to get 10, and then minus 5 times minus 3 would be 15. So 10 plus 15 is 25 as required. And then your wee answer line, just say answer, ANS, x is equal to 5, y is equal to minus 3. And that's it. Okay, this is a bit of a tricky one, this one. The way they've written it out for us. So what I would like you to do is just rewrite it, and I'm going to bring all the x's to one side. So bring it all to the left-hand side, all the letters to the left-hand side, everything else to the right. So you're going to have minus 6x plus y is equal to 17, will be your equation 1. And 5x plus 4y is equal to 10 is your equation 2. Similar example to the last one. What we've got to do is we're going to say we're going to eliminate the y. And why we're eliminating the y is there's 1y in the first equation and there's 4 y's in the second. So what we can do is multiply the equation 1 by 4 and see what we get. You're going to get minus 24x plus 4y is equal to 68. And then 5x plus 4y is equal to 10. And that is equation 2. Okay, right, if we have a look at our y's, the thing we're trying to eliminate, there's 4y in both, we're now good to go, and they're both positive. That means we're going to subtract. So I'm just going to do 4 times equation 1 minus my equation 2. So minus 20, and just be careful for these here, minus 24x minus 5 is minus 29x. 4y minus 4y is 0. 68 minus 10 is going to be 58. And then you can say then x is equal to 58 divided by minus 29, which means x works out to be, and that's just going to be minus 2. Okay, we're going to sub into equation 1 again. Sub into equation 1, you've got minus 6. I'm using my equation 1 here, I'm using this one here, sorry. Minus 6 times the minus 2 plus your y is equal to 17. And you're going to have then 12 plus y is equal to 17. Y then is equal to 17 minus 12. scroll down here. So my y works out to be 5. Okay, what you can do is again is check in equation 2, check in equation 2, and you have got, if I could see my equation 2, that would help. And my equation 2 was 5 times my x, which is minus 2, and plus 4 times my y, which was 5. And that would be 5 times minus 2 is minus 10, plus 4 times 5 is 20. So minus 10 plus 20 is 10 as required. So your answer, ANS, x is equal to minus 2, and your y is equal to 5. We're going to look now at the substitution method. It's just another way of doing these equations. In this method, a variable from one equation is substituted directly into the second equation. The resulting equation is then solved for one variable. This method is very suitable for a pair of simultaneous equations where we have a variable with a coefficient of 1. So a coefficient of 1 means that the number in front of the thing is 1. So here, for example, you've got y, the coefficient of y is 1, because the number in front of it, if you had drawn it in, would have been a 1. And likewise here, the coefficient of this a is 1. That's all that means. So again, I'm going to just say equation 1, and that's equation 2, and I'm going to say sub equation 1 into equation 2. So in equation 1, we know that y is equal to 1 minus 2x. So that means everywhere I see y in equation 2, I'm going to replace it with 1 minus 2x. So my equation 2 will become 3x plus 4 times my y, which is 1 minus 2x, equals minus 6. And then just multiply out, so you have 3x plus 4 minus 8x is equal to minus 6. That's a mess, so tidy it up. I have minus 5x is equal to minus 10. So what I've done is tidied up. I've collected the 3x and the minus 8x to give you minus 5x. And this plus 4 is going to cross the other side. So minus 6 minus 4 is equal to minus 10. And then you can go on from here. X then is equal to minus 10 divided by minus 5. 10 divided by 5 is 2. Minus divided by minus is positive. So it's going to be x is equal to just positive 2. What you then do is you sub back into equation 1. So you sub that back into equation 1. So y was equal to 1 minus 2x. So that's 1 minus 2 times 2, which is equal to 1 minus 4. So your y then is equal to minus 3. Next example, what we have to do first, I would rearrange and make a the subject. So I'm going to have 2b minus 10, and I'm going to call that equation 1. So I did that by rearranging this equation up here. And that's my equation 2 still. I'm going to say sub equation 1, my new improved equation 1, into equation 2. So instead of a, I'm going to write 2b minus 10. So I've got 3 upon 2b minus 10 plus 4b is equal to 4. And then multiply out, you'll have 6b minus 30 plus 4b is equal to 4. I'll show a wee bit more working out here this time. I've got 6b plus 4b is equal to 4 plus 30, which means 10b is equal to 34, which means b is equal to 34 divided by 10. B works out to be 3.4. Okay, you found your b. What you're going to do is sub that back into equation 1. We'll just say that sub into equation 1. And your equation 1 was a is equal to 2 times the b, which is 3.4, minus 10. And you can do that on your calculator. But 2 times b, it's going to be 6.8 minus 10. And how we can do that without our calculator, you can just do 10 minus 6.8, which would be 3.2. And then because of 10 is the bigger of the number and it was negative, the answer is minus 3.2. So a is equal to minus 3.2. We're going to look now at how we can use simultaneous equations to solve real-life problems. The following steps should be taken. So use 2 different letters to represent the unknown quantities. Write the given mathematical information in the form of the two equations. Solve the equations simultaneously. Check that the two solutions fit the original mathematical information and use the solutions to answer the original question. So we're going to look now at a few examples on how we do this. This example says the sum of two numbers is 32 and their difference is 4. Find the two numbers. Okay, I'm going to just say let numbers be x and y. So the sum of the two numbers, so the sum of numbers means them added together, x plus y equals 32. That's the first equation. And then the difference is them taken away from each other, so x minus y is equal to 4. And there's our two equations. What we want to do then is to solve these. So what I'm going to do is I'm just going to add equation 1 and 2. And if I add them, I will get 2x is equal to 36. And I'll just go over here. I've got 2x is equal to 36. That means x is equal to 36 divided by 2, which means x works out to be 18. And then we will sub into equation 1. Sub that into equation 1. You're going to have 18 plus y is equal to 32. And we'll finish this off over here. That means that your y is going to be equal to 32 minus 18. Your y is going to be equal to 14. Okay. Last part of our instructions earlier on, it said find the two numbers. So just answer your question. Just say the numbers are, and the two numbers were 14 and 18. And you can see if you add 14 and 18, you would get 32. And the difference between them is 4. This example says 5 apples and 3 oranges cost £1.35, whereas 3 apples and 5 oranges cost £1.45. Find the cost of 1 apple and 1 orange. Okay, I could use A is the cost of an apple and then O is the cost of an orange, but O is obviously going to get confused with a 0. So I'm going to avoid doing that. And I'm just going to use x and y. So I'm going to say clearly what I'm letting things be. So I'm just going to say let x be the cost of 1 apple and y be the cost of 1 orange. Okay, so the first line it says 5 apples, so it's 5 times x plus 3 oranges, 3y is equal to, and I'm going to do this in pence, 135 pence. And whereas it says 3 apples plus 5 oranges costs £1.45. Find the cost of 1 apple and 1 orange. Okay, right, this question is actually a lot harder than the ones we had seen earlier on in our examples. So we're going to have to do something a wee bit different to get this. Now, trickier because if you have a look, I've got 5 x's and I've got 3 x's in this one. Likewise, I've got 3 y's and 5 y's in this one. So it's not like I can multiply my first equation by something to give me 3 x's plus 3 x's, or I can multiply my first equation by something to give me 5 y's. So it's a wee bit more awkward. So what I'm going to think about is fractions. If I was adding 1 over 5 plus 1 over 3, hopefully we would know that you would have to take a common denominator and make them both over something over 15. So it's the same idea. So think here, what did you need to multiply that 5 by? You need to multiply it by 3. What did you need to multiply that 3 by? You needed to multiply it by 5. So it's the same idea here. So I'm going to pick to eliminate my x. And I'm going to do that by doing 3 times equation 1 and also by doing 5 times equation 2. So if you do 3 times equation 1, what you're going to get is 15x plus 9y is equal to, and 3 times, 3 times 135 is 405. Same idea, multiply your equation 2 by 3, you'll have equation 2 by 5, you'll get 15x plus 25y is equal to, and 5 times 145 is 720. and 25. If you then subtract, and I'll just do 3 times equation 1 minus the 5 times equation 2, you'll get minus 16y is equal to, so 405 minus 725 is minus 320. Your y then is equal to minus 320 divided by minus 16. So y works out to be equal to 20. So we've got our y is equal to 20. What we're going to do is just sub back into equation 1. So your equation 1, remember, was 5x plus 3y. So instead of y, we're going to write 20 is equal to 135, which means 5x plus 60 is equal to 135, which means 5x is equal to 135 minus the 60, which is going to be 75. X then is going to be equal to 75 divided by 5, and 75 divided by 5 is going to be 15. So now we have to answer the question. The very last part of the question says find the cost of 1 apple and 1 orange. So we'll just say 1 apple costs, and the apple cost was 15, so 15 pence. 1 orange costs, and it was 20 pence. Your y was 20, so 1 orange costs 20 pence. Done. This example says a bag contains 40 coins, which are either 2p coins or 5p coins. If the total value of money is £1.55, find the number of each coin in the bag. First thing I'm going to do is set up my variables. So I'm going to say let x be the number, so abbreviate number to NO with wee dot, number of 2p coins. I'm going to say let y be the number of and 5p coins. So it says a bag contains 40 coins. So this is a bit that most people miss. So a bag contains 40 coins. So that means your number of 2p coins, which is x, plus your number of 5p coins, which is y, must add up to 40. And that's your equation 1. The next part then, I'll just erase that. And the next part then says if the total value of the money is £1.55, that means every 2p coin is worth 2. So you've got 2 lots of x. So you've got, because x is the number of 2p coins, and you've got 5 lots of y, because every 5p coin is worth 5 pence, 5 times the number of them, and that adds to 155, and that is going to be your second equation. So you have to say what you want to eliminate. I'm going to eliminate my x. So I'm going to do that by first of all multiplying my first equation by 2, so 2 times my equation 1, and then I will write down my second equation below it just to make life easier for me, and I'm just going to subtract. So what I'm going to do is 2 times equation 1 minus my equation 2, because I'm eliminating x, and the reason why I've subtracted, I'm eliminating x, and they're both positive, so if the signs are the same, then you subtract. So 2x minus 2x is 0, 2y minus 5y is minus 3y, and 180 minus 155 is going to be minus 75. Your y then is equal to minus 75 divided by minus 3. So I'll just go over here to finish that off. That means your y is equal to, and that is just going to be equal to 25. So again, we're just going to sub into equation 1. So your x plus 25 is equal to 40, which means x is equal to 40 minus 25, which means x is equal to just 15. So answer your question. It says you defined the number of each coin in the bag. So we'll just say answer there are 15, and x was the number 2p coins, so there are 15 2p coins, and y was your number of 5p coins, so 25 5p coins. Find the point of intersection of the lines with equations 9x plus 3y is equal to 30 and 6x minus 2y is equal to 16. So this is really a bit like our graphical solutions, where you would just solve these two equations, and you could have done this using a graph, draw the graph and solve them, but you can also use the algebraic method. So we're just going to write down the two equations. We had 9x plus 3y is equal to 30. That's equation 1. And we had 6x minus 2y is equal to 16, and that's your second equation. So again, we're going to have to pick what we're going to eliminate, and I'm going to eliminate the y. Now, there's no particular reason why I'm eliminating y. It's going to be tricky for both. So if you look at your y terms, you've got 3y and then 2y in one of the equations. So think again, if you were adding a half and a third, your common denominator would be 6. So you'd make that something over 6, and that would be something over 6. So this is your thinking for this example. So how you're going to make the first one, how you're going to make that 3y into 6y, is you're going to multiply it by 2. So your equation 1 gets multiplied by 2, and your equation 2 gets multiplied by 3. So we'll just do that now. 9 times 2 is going to give you 18, so 18x plus 6y is equal to 60. And 3 times the 6 is going to give you 18x. And then that's going to be minus 3 times the 2y is going to give you 6y. And that is going to be equal to 3 times 16 is going to be 48. So here we're trying to eliminate your y, and you've noticed that the signs of the y's are different. So you can see your signs of the y's are different. That means you're going to add. So I'm going to take my 2 times equation 1, and I'm going to add it to 3 times my equation 2, which is going to give me 36x is equal to, and it's going to be 108. And then you're going to say your x is equal to 108 divided by 36. And you can check out in your calculator, 108 divided by 36 is just equal to 3. I'll put that in a wee square. Going over here then to finish this off, we're just going to sub into equation 1. So it was 9 times the x, which we now know was 3, plus 3 times y is equal to 30. So 27 plus 3y is equal to 30. 3y then is equal to 30 minus 27. So 3y is equal to 3. Y then is equal to 3 divided by 3, which is 1. So y is equal to 1. Read the question again. It says, find the point of intersection of the lines. So your answer, your point is a coordinate. It is 3, 1, and that is us done. So there's your video on all the different ways that we can solve simultaneous equations.